Okay, so let us talk about why pull-up resistors are needed at the gate of a pMOS in case of high-side switching application. So, in general, most pMOS used in high-side switching application have a VGS value of -2 to -4 volt, and your applied VGS, the threshold value of -2 to -4 volt, and your applied VGS needs to be less than this threshold value. What is VGS? VGS is nothing but the VG minus VS, that is voltages respectively at gate and at source. So this is VGS. See, but say we have for the switching application, we have a 12 volt applied at the source of the pMOS. Now in that case, let us see what happens when we apply different voltages at VG. So let's say case 1. We apply VG of -5 volt. Thus VGS equals to -5 volt minus 12 volt, that is -17 volt. That is obviously less than the threshold voltage. Thus your MOS is on. Then there can be another case when you apply VG equals to 0 volt, or gate terminal is simply left in a floating position. In that case, your VGS equals to 0 volt minus 12 volt equals to -12 volt, which is less than VT, and MOS is on. But this we do not want. We do not want to accidentally turn on the pMOS. So when there is no voltage applied on the gate and my pMOS is on, then we shall have no control over the switch. To avoid this, we shall need a pull-up resistor from the gate to source. You can call this RGS. What does the RGS do is, it gives us the case 3, that is when there is no gate is floating, okay, the external voltage given at the gate, then your VG will be pulled up to 12 volt because it is pulled through the resistor. Note that gate does not take much current because of the capacitor. Once the capacitor is charged, the gate, the MOS capacitor, that what we call the MOS capacitor, will not get much current. So the current flowing for through RGS will be 0, taken from the 12 volt, will be 0. Thus this 12 volt will appear at gate, as there is no voltage drop, there is no current flow through RGS, so there is no voltage drop through RGS, so 12 volt will directly, as if it will appear at the gate. So your VGS will be 12 volt minus 12 volt is equal to 0 volt, which is not less than VT. So now that your threshold voltage condition will not be followed, thus your MOS will be off. So you can prevent accidental turn on of the MOS. Similarly, in case of an NMOS, in low side switch arrangement, as shown here, we require a pull down resistor from the gate to source. In this case, in case of NMOS, we need to maintain VGS greater than VT, a certain positive value, mostly VT values are greater than 0 volt, VT, to turn the MOS on. So we need a pull up resistor to pull the gate down to the source so that we don't accidentally turn on the MOS again in case of it is floating. Okay.